Okay, so double angle formulas. Before we get into what a double angle is, let's talk about what it's not. Oh, dang it! Can you guys hear that? Do you watch these videos? Can you hear me?
Anytime you make weird noise, you hear it.
Oh, okay, good. Good. That's why I do it. That's why I do it. Okay. What a double angle is not, right? So if you can put a constant, a number, into a trig function in different places, and before we put it into a new place, I just want to talk about what these are, right? 2 sine x could be 2 times sine x, but that's also the same as sine x plus sine x. You've heard me say before, that we treat the trigonometric package as a variable. Okay, like 2x is 2 times x, but it's also x plus x. The same thing applies here, right? We talked about what this means. Okay, sine of 2x, sine squared x is really this, which is really this. So we use the exponent when we're multiplying 2 sine values together. We use the coefficient when we're adding 2 sine values together. But sometimes the 2 is going to show up on the inside, right? Remember that we can't operate onto this number 2 when it's inside the trig function. So like this is not true, right? We can't divide that by 2 and say sine x. Never, ever do that. Okay? What is sine of 2x? Here's one way to think of what sine of 2x is. So this is the double angle that we're talking about. And you're going to hear me say this throughout various points when we're going through these problems. Double angles and single angles do not play well together at all. Okay? What do I mean by that? I'll tell you that, well, let's talk about what it is first. So sine of 2x could be this. Right? I could just express the 2x as x plus x. So Ethan was asking, like, what is a double angle? A double angle is really a shortcut for an expansion of a sum formula using sine. So if we did use what we learned about yesterday with the sum formulas for sine, and we expanded this, we would get sine x cosine x plus sine x cosine x, and those are similar terms. So we have 2 of those. So if you look at the identities sheet that's in Schoology, that's the equivalence statement. So double angles are formulas, shortcuts, substitutions, call them whatever you want, for finding the sine of the same angle twice, like this, right? Using a sum formula. Okay? So you'll want to write this down, okay? Because that's the substitution. That's like saying cosecant is 1 over sine. Sine of 2x is equal to 2 sine x cosine x. Okay? And I'm going to write this over here to a point where I think even the people at home will be able to see it. Don't make this terrible mistake. Okay? This does not equal this. Just so we're clear. You can't, like I said before, you can't operate on what's inside that. Okay? So this is not true. Don't make that mistake. Right? What about cosine double angles? Oh, I missed it. Cosine double angle, we could go through the same process to show that it's equal to this. Now if you look at the identity sheet that we have, and again, it's really like proofs, okay? In fact, one of the proofs that we didn't get a chance to do yesterday because of time was I wanted you to verify that cosine of 2x is equal to 1 minus 2 sine x. okay? And we'll talk about why that is. We can talk about that here in a second. This is one equivalent statement for the cosine of 2x. Like, how does that work? If I did that, like, and this is a proof, right? Here's our proof. The cosine of x plus x is equal to cosine x, right? We take the cosine of each of these, put them together in a product, and then we subtract the sine of each of those and put those in a product, right? Remember when we're expanding the cosine of a sum, we use the opposite operation over here. And then cosine x is this, right? So here is one equivalent statement for what a double angle of cosine looks like. And again, I will tell you, single angles and double angles do not play well together. If you're doing a problem, solving an equation, which we're going to start next week, simplifying or verifying, and your problem has double angles and single angles in the same problem, immediately replace the double angle. We don't want to play with those. We don't mess around. Okay? Now, you know that each one of these separately could be expressed in terms of the other. What do I mean by that? Cosine squared x is also, and I'm going to erase this so we don't think that this all flows together. Okay? Cosine squared x is also 1 minus sine squared x minus sine squared x. So a different representation of this would be 1 minus 2 sine squared x. So this is also, in fact, why don't I do it like this? This is also equal to cosine 2x. You're like, why does that matter? It matters because if we start looking at simplifications and verifications, which we're about to do in a little bit, and the problem that I'm looking at includes sine and sine only, I would want to make this substitution. I wouldn't want to make that substitution and bring a cosine into the problem if I didn't have to. Okay? And the same thing can be said for, what color do I want now? Blue. The same thing could be said for sine squared. Okay? Sine squared is, does everybody have this written down? Let's do one more. Okay? Let's do one more. Sine squared is 1 minus cosine squared. So if I wanted a substitution for the double angle of cosine only involving cosines with single angles, it would look like this. Careful here with that negative. We'd have positive 2 cosine squared x minus 1. So, we also have this equivalent statement down here. So all three of these are equal to the double angle for cosine. Why don't you figure out what's the double angle for tangent equal to? Go. In other words, what's this? Here's your first hint. we use the sum formula for tangent. The tangent of the first plus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. When I say first and second, I mean first and second part of the binomial. So we get 2 tan x over 1 minus tangent squared x. Everybody okay with that? So here's our, if you wanted to substitute in place of tan 2x. All right. Here's a fun problem that I don't know if I want to do it right now. I'm not going to say this is extra credit. And I honestly don't know if that's true, but my assumption is that it's true. But I'm wondering if we could like take this, right, and put it over one of these 3 identities and get tangent squared. I don't know. If you want a challenge on a Friday, go for it.
Is there an
Wait,
identity that
so-
leaves the 1 minus